Today, I will be presenting my project, lactase-mediated degradation of low-density polyethylene and polystyrene via the invasion and ingestion by Pleurotus austratus. First, more than 1,000 tons of plastic are produced and thrown into landfills each year. This plastic includes low-density polyethylene found in plastic bags and polystyrene found in packing peanuts. And these plastics are able to be recycled, but they are often not cost-effective and can pollute the environment more frequently. Instead, using enzymes and fungi as a biodegradable approach to effectively break down plastic has recently been researched. I propose a two-step method for biodegradation of plastic by first using lactase, a copper-based enzyme that is able to oxidize the phenolithic substrates or the surface of the plastic, creating reactive radicals that break down the plastic's carbon-carbon bonds and creating carbon polymers that then Pleurotus austratus, oftentimes called oyster mushroom, a wood-rotting mushroom as we can see here, contains enzymes that are able to break down the carbon polymers in the plastic into carbon monomers that can effectively go into the environment without harming it. Moving on. For my experimental design, my research question and purpose was to assess whether a two-step approach for degradation, first using lactase enzyme and then using Pleurotus austratus, will accelerate the breakdown of plastic. My hypothesis was whether the inclusion of lactase enzyme onto polyethylene and polystyrene would accelerate the degradation process of the plastics while being fed to Pleurotus austratus. For materials, low-density polyethylene and polystyrene sheets were used, lactase enzyme in powder form, Pleurotus austratus culture syringes, and the use of the scanning electron microscope. For procedures, lactase application to plastic sheets was applied every 3 days for either 0, 15, or 30 days, and 5 milliliters of this solution was applied. After these days were up, a fungal treatment was added to the plastic by placing the plastic face down onto sheets of agar covered in Pleurotus austratus, where they were left to be invaded and ingested by the Pleurotus austratus for 15 days. Moving on, we can see on my results that there was significant weight loss in both polyethylene and polystyrene plastics with lactase enzyme exposure, with 30 days having the most enzyme exposure, and my control group having no change. The same can be seen in the polyethylene and polystyrene plastics with mushroom or Pleurotus austratus exposure, with the no enzyme exposure having no change, indicating how lactase is a significant first step to later ingestion by Pleurotus austratus. Same can be seen in overall density changes from before enzyme application to after fungal application, where density changes can be seen no enzyme exposure with no changes to 30 days of enzyme exposure having the most changes in density. For the scanning electron microscope, the control group, as can be seen in this first image, had no scratching or color changes, while 15 days of enzyme application for polyethylene did have some scratches and color changes, while polyethylene for 30 days actually had a mushroom break through the bottom of the agar to the top of the plastic, where Pleurotus austratus was able to degrade the plastic. For polystyrene, it can be seen the same thing from the control to 30 days of degradation. In conclusion, there's a significant potential of a combined enzymatic and fungal approach for plastic degradation, and this can be shown through the control groups having no enzymatic changes or fungal exposure. There's no signs of plastic degradation. For applications in future research, this offers a low-cost, eco-friendly degradation of plastic that can be featured in companies in industrial scaling or even in the comfort of their own home with no byproducts. And for future research, it would be good to analyze environmental conditions, as this was in a laboratory setting. For error analysis, there might have been some weight measurement errors, and a Friedman test was conducted to conclude significance, where all my data sets were found significant with a p-value of less than 0.05.